Afternoon, everyone. I'm Rishabh Goel. I'm a master student in CS at IIT Delhi. Today I'll be talking about document similarity metric, which is known as word movers distance. So first of all, let us try to understand why document similarity is being talked about and why is it a very difficult task. So as you can see, these two sentences, the Cilician gelato was extremely rich, the Italian ice cream was very velvety. They in some sense have same content, but as you can see, there is no same word in between in the two sentences. So if we use the traditional, conventional ways of calculating the document similarity of bag of word vectors or TF-IDF. So these two matrix basically considers the occurrence of a word in a sentence as a metric for document similarity. So if two sentences don't have any word in common, then we might get a zero similarity, even though the similarity exists. So over the course of time, some other techniques have come up which are known as LSI and LDA. On a very high level, these two techniques considers the document as a linear combination of topics. So you could get a you can get a better performance over the document similarity using these two matrix. But now another quantitative metric of document similarity has come up, which is known as word movers distance. So this word movers distance is based on Google's word2vec vectors, and it's based on the well studied concept of Earth movers distance in transportation theory. So this it has a very great importance because it beats all the conventional state of the art techniques for calculating the for calculating the document similarity. I think with a great milestone. So this is the paper. You may read about you may read more about it on this paper, and on a very high level, it is doing that this this optimization, and to get to get you an idea of what word2vec is, as you can see in the blue box, the Cilician gelato was extremely rich. The Cilician is very close to Italian, and gelato is very close to ice cream. So word2vec vectors basically capture the semantic information that is there in the sentences. And on a very high level, word2vec is basically a co-occurrence statistics that that makes up the vector in a higher dimensional space. So there are WMD is as I said, WMD performs this optimization. So there are two other matrix known as so there are two other matrices known as word centroid distance and relaxed word movers distance. So basically they are the they are lower bound for word movers distance. And if you want to, you have thousands of documents and you want to get most case similar documents out of them, you can use these as a way to prune the word movers distance computation, because it is performing, it has a lot of constraints and takes a lot of time, which might be a problem. So these can be used to prune the WMD distance calculations. This graph here shows the distance of a Twitter tweet from other tweets that were present in the corpus, arranged in the ascending order. The lower ones, this is the WCD. The red ones are the RWMD, and the blue ones are the WMD. So you can see RWMD is the lower bound for WMD distance, and it can be used as a metric for good metric for calculating the similar distances. And this word mover similarity is implemented in GenSim library. And you can see the main thing I would like to point out is that the query sentence very good. You should sit outside. And the first output sentence, it's great base if you can sit outside in the good weather. They don't have any word in common. So this is I think this is the power of word movers distance, that it is able to, on a very fundamental level, able to capture the semantic similarity. So that's more or less about it. Like, I have a open space talk in which I would like to I will be giving a more hands-on experience tomorrow at 12 p.m. So those of you who are interested may turn up at 12 p.m. in open space. Thanks. And the link to slides is on this link.